Okay, friends, let's see if we can do this particular problem. I think we can. We have a problem here where this great French chemist, Antoine Lavoisier, he was great, very interesting person who discovered this idea of the law of conservation of mass, and he did this experiment. In this experiment, he found that mercury oxide, so HgO, when heated, decomposed into liquid mercury, so mercury, plus this invisible and unknown substance at the time, oxygen gas. Okay, that's the chemistry that's going on. So the first thing we're supposed to do is write a balanced chemical equation. Okay, I can envision a question like this being on our test, and then it gives us some volume, a temperature, a pressure. So I can imagine I'm going to have to use the ideal gas law to solve this particular problem. Okay, so let's go ahead and write that balanced equation. This should be easy. I think if we put a 2 there, that balances the oxygens, and puts a 2 there, it gives us a balanced equation. Okay, and so it says, suppose that 22 mils, so we'll know with the ideal gas law, we're going to have to get that into liters, of dioxygen gas are produced from this reaction at a given temperature and pressure. Calculate the mass of mercury oxide that must have reacted. So we can measure this, and then based upon the stoichiometry, we should be able to go back and find out how much mercury oxide decomposed. Okay, let's write the ideal gas law. We know that PV equals nRT. And notice that moles, N is moles. These moles, if I can calculate the moles of oxygen, then I can use stoichiometry to get back to mercury oxide. Okay, let's just rearrange this equation then. Let's go N equals PV over RT, and let us get our values. P equals 1 atmosphere. Should be easy to do that. So that's what our P equals. Volume equals 0.0220 liters. I just converted that in my head into liters. Our temperature is going to be 70 degrees. Okay, I'm going to try to convert that in my head. That'd be 343.15 degrees Kelvin. And R equals 0.08206. We'll go with that. Okay, if you put these into this ideal gas law, then that will give me the number of moles. Okay, then if I get those number of moles, whatever that answer is, I get a certain number of moles of O2 gas. I know that for every 1 mole of O2, I'm going to consume 2 moles of HgO. I get that from this stoichiometry right here. And then finally, I can use this. It wants the answer in grams. I can say for every 1 mole of HgO, then I think it's 216.5, something like that. Okay, so these are moles. Okay, so let's, I guess, go ahead and put that in. So N equals 1 times 0.0220 divided by 0.08206 times 343.15. All right, let me get out my calculator, see if we can't do this problem. Okay, I have 0.0220 divided by 0.08206 divided by 343.15 equals, that gives me N equals 7.8128 times 10 to the minus 1, 2, 3, fourth. Okay, this is my number of moles right here. Okay, so let's go ahead and bring this back over, go this way, right here. Okay, so I'm going to take that number, I'm going to multiply it by 2, so times 2, and then times 216.5 equals, I get for my number of grams, okay, this is grams coming out of here. When I do this math, I put 7.8228 times 10 to the minus fourth. I put it in here, and my answer is going to be 0.338. I'm looking at sig figs, and I got 3, and 3 sig figs is going to govern me here. So I have 0.338 grams, and that is my final answer. Okay, so we can do these. What's the steps? Write down the correct chemical equation and balance it. Then, once you see this in a problem, you got to think, oh my gosh, I'm probably going to have to use that ideal gas law. So we use that ideal gas law to get the number of moles. Once we have the number of moles, we go back to the stoichiometry that I did right here, and we get our answer. Okay, these are way doable. They're kind of 2 steps, maybe 3 steps. Write the chemical equation, solve for the number of moles, put that moles back into your stoichiometry, and get the number of grams, in this case, of mercury oxide. All right, my friends, we can do this.